Hello and welcome to your third lesson in basic math training. Today we have something a bit different on tap. We are going to be learning how to place different fractions and decimals in order together, from least to greatest, greatest to least, everything in between. I don't actually think there's anything in between there, but if there is, we're going to go through it. It may sound intimidating at first, comparing fractions and decimals together. How do we do that? But don't worry, we're going to break it down, and when we do break it down, on the dance floor, not actually. It's actually not so bad, not so complicated. And remember, when we are together, there's nothing that can stop us. So it's gonna be all right. It'll be all right, kid. Stick with me. These skills are gonna be crucial to us succeeding on our what? On our quest. On our quest for what? Our quest for the GED. We got this. Let's begin. Okay, so let's say that you encountered a problem like this that said place the following in order from smallest to largest. And so they give us a fraction, they give us a decimal, another fraction, and another decimal. And they're asking us to put these in order from smallest to largest. Another way that they might say that sometime, in case you ever see this, is put these in order from least to greatest. That means the same thing, smallest to largest. And so you might look at this and say, okay, well, you know, I can see that this decimal and this decimal, I know how to put those in order. But what do I do with these fractions here? Because it's hard to really compare, like what is 1/4 1/4 compared to 0.3, and what is 5/7 compared to 0.6? I don't really know what to do here. And there are a couple different things that we could do. Because it's hard to compare fractions and decimals together, what we want to do is we want to either turn all of these into fractions or turn all of them into decimals. Because if they're all in the same form, then it's really easy to look at them and compare. And so you could take this decimal and you could turn them into fractions. And then you could try to compare them that way. But to be honest with you, that was going to be a lot more work, because I could turn these into fractions pretty easily, but then in order to compare fractions, you need to make all of the bottom numbers, all of the denominators, the same. And in order to make all the denominators the same, we'd have to find a least common multiple of all of the different denominators, and it would just be a lot more steps. And so I think the easiest way to do this is to actually take the two fractions and turn them into decimals. And so the way that we're going to do this is we're actually going to do exactly what the numbers are telling us to do. So this fraction here, 1/4, what this is actually saying is it is saying 1 divided by 4. Same with this fraction here. This is saying 5 divided by 7. That's what a fraction really means. And so all we have to do is carry out the division, and that's going to tell us exactly what this is equal to in decimal form. And so if you're allowed to use a calculator, it's really easy. You just type in 1 divided by 4. That gives you a decimal. However, with this type of question, I got a hunch that you're not going to be allowed to use a calculator to do that, because that would be too easy. And so the way that we are going to do this is we're going to use our old friend, Mr. Long Division. Now, if you just had a panic attack and you're like, oh my gosh, long division, I hate long division, I don't understand long division, I want you just to take a deep breath right now, because remember, you may have been taught long division before, but you have not been taught long division by the calculator educator. We make things simple here. I got you. Do not worry. We are going to go through it step by step. It's going to be as easy as a lemon squeezy, and you're going to leave this video knowing exactly what to do. Okay, so let's start with this fraction here, because he's at the start. So the first step in long division is to draw this little, I don't know what you want to call it, half rectangle. Okay, and then we have to put one number in here and one number in here. The number that goes in here is going to be the top number. It is the number that we are dividing. And then the number that goes on the outside is the bottom number. That's the number that we are dividing by, right? I am doing 1 divided by 4. So the 1 is what's being divided, the 4 is what we are dividing by. Okay, so I got my 1 in there, I got my 4 in there. Nice and simple so far, right? I think so. And then the next step is I say, okay, how many times does this number out here go into this number in here? How many times does 4 go into 1? And you might say, what are you talking about? Have you lost your mind? 4 doesn't go into 1. 4 is bigger than 1. If I start counting up by 4s, right at the start, I'm already past 1. I start 4, 8, 12. 4 doesn't go into 1. Calculator educator, what are you talking about? You're absolutely right. That is why our answer is going to be a decimal, because it doesn't go in 1 time, it doesn't go in 2 times. It doesn't actually go in at all. That's why we're going to get a decimal. All right? So how many times does it go in? It goes in 0 times. So I'm going to write a 0 up here. Okay, and now what we need to do, because 4 doesn't go into 1, I need to make this number bigger so that 4 can go into whatever it is. And so what I'm going to do is I'm going to draw a 0 here. I'm going to take it and turn it from 1 into 10. The reason I do that is because 4 can go into 10. However, I need to make sure that I'm not actually changing this number, right? Because that would change the question. I'm not doing 10 divided by 4. I'm doing 1 divided by 4. So to make sure that this number stays the same, I'm going to draw a decimal in there. That makes this 1.0, which is the same thing as 1. And then because I drew a decimal here, I have to make sure I draw a decimal exactly parallel in my answer. So I put a decimal after the 0. Okay. So all I did there, I added a 0 to turn this into a 10 so that I can do my next bit, and then I just drew my decimals in there. And now what we say is that, okay, how many times does 4 go into 10? If I count out by 4s, how many times can I go? So I go 4, 8, 12. Okay, so it can't go in 3 times because that passed 10, but it can go in twice, right? 4, 8. So because it goes in twice, I'm going to write a 2 up here. And then I say, okay, well, what was 4 times 2? 4, 8. Whatever that number is, in this case it's an 8, that's what I draw underneath. Now I've got a 10 here, I've got an 8 here, and then all I have to do is subtract. I know this is a lot of steps, don't worry. We're going to go through it a number of times. The more you do it, the better you'll get at it. So don't worry if it's a lot of steps and it's confusing. The more you do it, the more it'll make sense. Okay, so I write my 8 down here, and then all I got to do is subtract. Remember, we're treating this like it's a 10. Okay. So 10 minus 8, what would that leave me with? That would leave me with 2. Okay. How many times does 4 go into 2? Well, it doesn't go into 2, right? So I got to draw another 0 over here, bring it down, and turn this into a 20. Again, 1.00, that's the exact same thing as 1. Any number at all, you can always add a 0.00000 to it. Doesn't change the number. Okay, so I make this a 20. And now I just repeat the exact same process. I say, how many times does 4 go into 20? 4, 8, 12, 16, 20. It goes in 5 times. And it actually goes in evenly. That's good news. I'll tell you why. Okay, so it goes in 5 times. What is 4 times 5? What did that get us to? 4, 8, 12, 16, 20. It got us to 20 exactly. The reason that's good news is because when I write that down here, 20, and I subtract these two numbers, what's 20 minus 20? Well, that is going to leave me with 0, which means there's no remainder at all. It means we are done our division. It divides in evenly. And so we get an answer of 1 divided by 4 is equal to exactly 0.25. So that is what this fraction is in decimal form. It is 0.25. Okay, so we got one of our fractions done. Now we just have to do the same thing with the other fraction. So remember, our first step is to draw our little half rectangle shape. And then I got to put one number in here, one number in here. Do you remember which number goes in here? That's right, it's the top number. So 5 is going to go in here. And then the 7, the bottom number, is going to go out here. All right. Then I say, how many times does 7 go into 5? Well, Mr. Crazy Andrew, 7 doesn't go into 5. 7's bigger than 5. So what do I got to do? I got to add a 0 to turn this into 50, but draw my decimal so that that number doesn't actually change. And then up top, I gotta draw a decimal in the same spot. I forgot to draw the 0 here because 7 goes into 5 0 times. So that's my bad. Okay, got my 0, got my decimals, and now I just say how many times does 7 go into 50? Well, let's count up. 7, 14, 21, 28, 35, 42, 49. Okay, if I go one more, it's going to go over. So it only goes in 7 times. So I write my 7 here. And I say, okay, well, what was that number that I got to? It was 49, right? So I draw my 49 down here. I subtract my two numbers. What would 50 minus 49 be? You could do this the whole, turn this into a 4, turn this into a 10, borrowing, all that nonsense. It's not nonsense. I don't know why I said that. But you could go that way if you wanted to, but I just know 50 minus 49. That's going to give me 1. All right? And then I say, well, 7 doesn't go into 1, so I got to add another 0, bring him down, turn this into 10. How many times does 7 go into 10? Well, 7, 14, can't go that high, so it only goes in once. So I'm going to draw my 1 here, because it goes in once. And then I say, okay, what was 7 times 1? Well, that was 7. So I draw that down there, subtract my two numbers. 10 minus 7 is going to give me 3. And then you could keep going and going and going and going as long as you want. Some numbers aren't going to divide evenly, so you could actually keep going forever. All you really need is your first two numbers here in order to compare it with the rest of the decimals. Sometimes actually in this case you might only need the first one, but it's good to at least get your first two numbers just to be safe. For this question, I'm going to go one more. I'm going to find out what the third number is. Sometimes that's useful if you ever have to round, if you have to know, do I round this up or down? Sometimes it might be useful to get the third digit. You probably won't need to know this on your GED, but let's just do it one more time just to be safe. It also helps us to get more familiar with the process of long division, right? So how many times does 7 go into 3? It doesn't, so I'm going to draw a 0, bring it down, turn that into 30. Okay, how many times does 7 go into 30? 7, 14, 21, 28, 35. That's too much, so it goes in 4 times. So I draw my 4 here. What was that? 7, 14, 21, 28. Draw my 28 here. Subtract 30 minus 28 would leave me with 2. So as you can see, I could still keep going, but I don't need to because I've already got quite a lot of numbers after the decimal. And so I can say now, confidently, therefore, 5 over 7 is equal to 0.714 approximately, because technically the number keeps going, right? So we are kind of cutting it short, but for the sake of our question, this is all we need to know. Okay, so now that I have my fractions turned into decimals, now all I got to do is compare them to the other decimals and figure out what's the smallest number, what's the biggest number, and what's everything in between. So I can see if I replace my fractions, right, with decimals, then I would have, this would be a 0.25, and this would be a 0.714. And so now I just have to look at my 4 decimals and order them from smallest to greatest. So what decimal do you think would be the smallest? I got 0.25, 0.3, 0.714, and 0.6. Well, the answer would be 0.25. And you might say, well, why is that? Because surely 25 is bigger than 3. And you are right that 25 is bigger than 3, but when we're comparing decimals, all that really matters is the first digit. I just have to look at what's bigger, a 3 or a 2. And of course, a 3 is bigger, so that means this one's going to be smaller. And the reason that it doesn't really matter that this says 25 and this says 3 is because any decimal at all, you could always add zeros to the end of it. So this 0.3, I could technically write that as 0.30. I could also write it as 0.300, etc., etc. Anytime you have a decimal, you can always add zeros to the end. So that's why it doesn't matter that this technically says 25 and this one said 3. That doesn't matter. Just look at the first decimal and look at which is the bigger number, which is the smaller number. Okay, so 0.25 is going to be the smallest one. 0.3 will be the next. And then I've got 0.714 and I've got 0.6. Well, 6 is smaller than 7. And then last but not least, I will put this one in. And so there we have ordered all of our decimals from smallest to greatest. And then the last thing I would do is I would just swap out the decimals with what the original fractions were, because you want your answer to be in the same format as the question, right? So I don't want to write 0.25 as my final answer. I want to write it as its original form, 1 over 4. And so I would replace this with my 1 over 4 fraction. I'm going to keep this guy the same because he was 0.3 in the question. 0.6 was the same in the question, so I'll keep him the same. And then this decimal here, I'm going to replace him with the original fraction, 5 over 7. And so that would be your final answer, listing the fractions and the decimals from smallest to biggest. Okay, so now I'm going to give you another example, and I want you to try this one on your own. So use the example that we just went through, and I want you to try your best to figure out these two fractions and these two decimals. What is the smallest? What is the biggest? Everything in between. Try to order them, and then when you think you have given it your best shot, click play, and we will go through it together. So pause the video now, give it your best shot, and we will take it up in a minute. Okay, so now that you have given it a try on your own, let's go through it. So I can see I've got two decimals, I've got two fractions, and so I could turn these guys into fractions and then convert all the four fractions so they have the same denominator, but that's a lot of work. I don't want to do any unnecessary work, so let's do it the easier way. Let's turn these two into decimals. So I am going to start with my 4 over 7. So I'll draw my half rectangle shape, put my 4 in here because he's the top number, put my 7 here because he's the bottom number. All right, now I'm in business. So I say, how many times does 7 go into 4? Well, of course it goes in 0 times. Draw my 0 there. Need to make this bigger, so I'm going to draw my 0 here, but remember to put my decimal so I don't actually change this number. Because I put a decimal here, I have to put a decimal here. And now I say, how many times does 7 go into 40? Well, let's count up. 7, 14, 21, 28, 35, 42. Okay, that's too much, so it goes in 5 times. All right, and what was that? 7, 14, 21, 28, 35. So I write my 35 here. I subtract my two numbers. 40 minus 35 is going to leave me with 5. And then repeat the process. So 7 doesn't go into 5, so I draw a 0, bring him down. That becomes 50. How many times does 7 go into 50? 7, 14, 21, 28, 35, 42, 49. 56 is too much, so it goes in 7 times. And that got me to 49. So I draw my 49 down here. And I could keep going. I could subtract that. 50 minus 49 leaves me with 1. But I don't really need more than that. I've got 0.57. That should be enough to figure out where he fits in here. So I'm going to say 4 over 7 is equal to approximately, because I am rounding a bit, 0.57. All right, and now I just got to do the same thing with my other fraction, and I should be good to go. So my 1 goes inside, my 3 goes on the outside, 3 goes into 1 0 times. Draw my decimals, add my 0, turns this into 10 for the sake of our question. How many times does 3 go into 10? 3, 6, 9. Goes in 3 times. What is 3 times 3? 3, 6, 9. So I draw my 9. I subtract my numbers. 10 minus 9 gives me 1. 3 doesn't go into 1. Bring down this 0. Turns that into 10. Oh, I feel like I've done this before. How many times does 3 go into 10? 3, 6, 9. Goes in 3 times. 3, 6, 9. So I draw my 9. Subtract. What is 10 minus 9? That's 1. You might notice here, if I keep going forever, if I draw another 0, right, that makes this 10. How many times does 3 go into 10? Well, that's going to be 3 times. What is 3 times 3? That's 9. Subtract them. Gives me a 1. This is going to keep going forever. 1 divided by 3, technically, as a decimal, is 0.333333333 forever. It goes on forever. And so I don't want to spend the rest of my life doing this. I'm going to stop right there. And so my fraction is going to be equal to approximately 0.33. I don't need to write the other 3. It doesn't really change anything. I just need to know how it relates to these other decimals here. And so I've got this guy is going to be 0.33. I've got this guy is 0.57. And so now I just have to order them, least to greatest. And so my final answer what do you think the smallest one is of these? I've got 0.57, 0.5, 0.33, 0.6. Well, it's going to be the 0.3, right? Because 3 is the smallest of all these numbers. So we're going to go 0.33. Then, well, I've got a 0.5 here and I've got a 0.57 here. How do I know what's smaller? Remember, this 0.5, you can technically put a 0 after it. I could do it for this guy too. Anytime you have a decimal, you can always add zeros to the end of it, and it doesn't change the number. So this is technically 0.50. This is 0.57. And so if the first two numbers are the same, the first digits, they're both 5, then you defer to the second. And I say, what's bigger, a 7 or a 0? Well, of course, the 7 is bigger, which means this guy will be smaller. So my next number, if I'm going from smallest to biggest, is going to be this guy, my 0.5. Then I would have my 0.57. And then I would have my 0.6. That's a really question to go through, because if you encounter something like this and you have a 0.5 and a 0.6, you'll know where to put him. He goes right in between those two. And so I get my decimals in order, and the last step is just to swap out my decimals for the original fractions, right? So I say this 0.33, in the question he was 1/3, so I want to write him as that in my answer. So that'll be 1/3. 0.5 was 0.5 in the question, so he stays the same. 0.57, he was a fraction, so I want to replace him with the original fraction. And then 0.6, he was always 0.6, so we keep him the same. And so that would be my final answer, ordering those two fractions and two decimals from smallest to biggest. Okay, so now let's look at the type of question that you might face on your GED math exam. You might see something like this. It says, between which pair of decimals should 5/6 be placed on a number line? So basically, if this was all on a number line, which pair of decimals would this fraction be in between? And so in order to figure this out, we need to know what this is as a decimal, so I can know which two decimals it's going to be in between. So if you feel up to it, pause the video now, give it a try on your own, see if you can get the answer. And when you have given it a shot, press play, and we will take it up together. Okay, so now that you have had a chance to try it on your own, let's see what we can do. So like I said before, we need to figure out what this fraction would be as a decimal. And so in order to do that, we are going to do long division. So I'm going to draw my half rectangle, put my top number inside, my bottom number on the outside, and then I say, all right, how many times does 6 go into 5? 0. Draw my decimals, add my 0 so I can treat this as 50. How many times does 6 go into 50? 6, 12, 18, 24, 30, 36, 42, 48. Okay, so it goes in 8 times. If I go one more, 54, that's too much. So it's going to go in 8 times. And that number, what was 6 times 8? 6, 12, 18, 24, 30, 36, 42, 48. That was 48. This is also where it's handy to know your multiplication tables, right? If I know what 6 times 8 is, I don't have to recount up all the way. Draw my 48 there. Then I just say, what's 50 minus 48? That leaves me with 2. How many times does 6 go into 2? It doesn't. Bring my 0 down. Turns that into 20. How many times does 6 go into 20? 6, 12, 18, 24. That's too much, so it goes in 3 times. And then I could keep going if I wanted to, but I already have enough. I know that this fraction is going to be equal to 0.83 something, something, something. The rest doesn't matter. I just need to know these first 2 digits, 0.83, because that's going to tell me where it's going to fit into all of these decimals. All I need to say is, okay, this number, 0.83, which 2 decimals is that going to be in between? And so is it going to be in between 0.5 and 0.6? No, because it's bigger than both of those. Is it going to be between 0.6 and 0.7? No, because it's bigger than both of those. Is it going to be between 0.7 and 0.8? Again, no, because it's bigger than both of those, right? This 0.8 is technically 0.80. So this guy's still bigger. Well, what about this option, 0.8 and 0.9? Yeah, he's going to be exactly in between those, right? If I was to list these from smallest to biggest, I'd have 0.8 or 0.80. Then I would have 0.83. And then I would have 0.9 or 0.90, right? You can always add that 0 on if that helps you to compare. And so this fraction, which is this decimal, they equal each other. He is going to be in between these 2 decimals. And so D would be our answer. And that concludes our 3rd lesson in basic math training. Congratulations, you are once again one step closer to achieving that GED and sending that pesky mermaid back to where she belongs. Wherever that may be, I don't know. The skills you learned today will serve you well in the future, and they make you a more equipped person than you were about 15 minutes ago. So that's always a good sign. As always, I am, who am I? You guessed it. I am the calculator educator, saying 1, 2, 3, later you. I will see you. See you next time. Hey, thanks so much for watching. If you enjoyed this video, make sure to hit that thumbs up button and also make sure to subscribe so you don't miss a single episode. I am going to be covering the complete GED math curriculum. As well, if you are somebody who is currently studying for their GED math exam and you feel like you could benefit from some one-on-one tutoring, I am a professional math tutor and I currently have some openings for some new students, so feel free to either leave me a comment, send me an email at calculatoreducator@outlook.com, or send me a message on Facebook where my username is, of course, Calculator Educator. I will post a link in the description. Again, thank you so much for all of the support. I appreciate it more than you know. I hope you have an amazing day. See ya.